Hey, it's Clay. Welcome to another video. Today, we're going to go on an adventure. This adventure is centered around my 6AU6 Princeton combo amplifier that I built. It's my primary grab-and-go gigging amp that if I got to go to a gig or a rehearsal, need to bring an amplifier. It's my best combo. It's a single 12-inch. It's a good sounding amp. I've always enjoyed it. But there was a couple of things about it I wanted to improve, some kind of quality of life improvements. And as I got into it, as I started progressing through that, some different things keep popping up, some challenges. It's almost like I fix one thing, I break something else. And so if you're curious about how all that played out, this is going to involve a lot of troubleshooting, a lot of modification, tinkering, and in the end, we're going to see what I end up with. So if you're curious about that, stick around. Let's go ahead and dive in. All right, for the purpose of testing, I got my cheap, glary 335 that I actually really love. Go straight into the amplifier, and I'm micing it up with my large diaphragm condenser mic that I rebuilt. I'll have links down in the description to both those projects if you're curious. Now, let's talk a little bit about it. I'm just going to play for a little bit and go through some tones. This is kind of how I would typically set it up. We've got 4 controls. This is volume, treble, bass, and then middle here on the end. On-off switch, and then tucked underneath is a negative feedback control. So let's kind of get a little bit of a feel for the range of tones here. The other thing I want to note too is this whole thing, the volume control has been on 10. And I think a big piece of that is also related to, I've got this negative feedback control tucked away underneath here. Let's see if I can find it. So this current setting, I've got the mid-range control cranked, volume cranked, and the negative feedback is off. This is as dirty as the amp gets. Now the negative feedback is on. Now to me, this part is a little bit weird just because the volume is way cranked. So the negative feedback is on, the mid-range control is way down. This amp is extremely clean, like too clean. So if I kind of had to summarize the issues or the concerns that I have, that negative feedback control really isn't giving me much functionality. When it's on, the amp is just too clean. I don't know if it's that the 6AU6 preamp tube isn't able to push enough preamp signal, really with the limitations of the circuit that I chose, maybe it just isn't in the cards for it. So, second of all, that negative feedback control located on the back panel underside of the amp is really inaccessible. I have to kind of reach under and back where the tubes are, and you're kind of poking around there, and it doesn't feel very safe. The tubes are hot. You don't want to get burned. You don't want to be sticking your finger up into the amplifier. It just feels a little bit funky. And then second of all, I just, the way that these controls are laid out just isn't. And then lastly, I'm not 100% sure about this speaker. I might also experiment with testing out a different speaker. So let's get the amp out. Let's get it on the bench. Let's pop it open. Give it a good service. Do some rewiring. Maybe some tinkering around with the tone stack stuff. But, actually, before I want to do that, I'm actually going to get you guys on the computer and plug in the values that I've got into the tone stack calculator, and let's do a little bit of theory on tone stack stuff. All right, here's my little cheat sheet. I actually went through the amp and kind of tried to reverse engineer and draw it out. I also found an old schematic from an old video and went through that. All this stuff here in the 686 looks fine. I'm most interested here on what I'm doing here with the tone stack. Now, a couple things. I think I already had changed this mid pot to a 25K. At one point, it might have been 250K, so I was wrong there. Interesting how that your memory kind of fails. But I do kind of have some funky values. And so what I did is I pulled up the tone stack calculator and plugged all of my values in up here. And it looks fine-ish. You know, there's our treble control, sweeping our treble control, sweeping our bass control, sweeping our mid control. So, I mean, there is some good functionality here. But I do think I want to change some of these values. So I'm going to play around with this a little bit, compare it a little bit with the standard Fender, and see what I can do. All right, I pulled up a deluxe reverb tone stack. This is from Rob Robinette's website. Check it out. And I identified what I circled here are the three little tweaks. And it is kind of interesting how, that we're not far away, but even with some little subtle tweaks, it does change things. So we got a 220 picofarads. It should be 250 picofarads. The treble pot is 500K, and it should be 250K. And then our mid-range pot is 25K. So this is the existing tone stack, just kind of set with the bass on 4, mids on 2, treble on about 5 or 6. This is kind of how that curve looks. If I go back to the standard Fender, this is what it looks like with the standard Fender control. And so I think that what I'm hearing a little bit with these funky controls is just kind of a little bit of subtle tweaking to the tone stack being a little bit off. So I'm going to take this out. I'm going to return it back to a bone stock AB7663 deluxe reverb or Princeton reverb type tone stack. All right, I've got a 250K. This actually is like for a guitar pedal, but I think it's going to work just fine. Then I've got a 1 meg. I'm actually going to use this to replace the volume pot. And then this is a 10K. I'm going to use that to replace the mids pot. And then I've got a 250 picofarad capacitor for the treble control. So let's get those in. Well, sometimes I just can't leave well enough alone. I was thinking more about how the amp didn't have maybe the highest amount of power and headroom and output. It's just kind of a cleaner amp. So give it a little more juice. This is my tube rectifier slot. I've actually installed two 1N5408 diodes, solid state diodes. So what that's going to do is basically raise the amount of voltage going through the entire amp, because these diodes are going to be more efficient than the tube rectifier, which has a little bit of loss. So the high voltage AC comes in these two red wires, goes into the diode, and it comes out the other side rectified, and these two yellow wires send it to the filter cap and the B+ supply. So the amp will need a rebias because the power tubes are not going to be biased properly at this point. Also, I need to make a mental note that this amp will no longer support a tube rectifier. If you put a tube rectifier in there, I have no idea if these pin layouts are correct. I'm just using them basically as a terminal strip. So I'll probably put some kind of protective cover on the top to prevent myself from doing that. Yeah, the amp is done. If we take a look at this side, we've got new volume, new treble, old bass, new mid. I got a new treble capacitor. I checked the values on all these guys. I just put a bunch of new wires in there, kind of cleaned things up. Got a little bit of heat shrink in spots where it maybe was needed. And things are looking good. All right, I've got the amp plugged into my light bulb current limiter over here, which is plugged into the power outlet. I do have a speaker plugged into here. Let's fire it up, see what happens. Well, this 6v6 started burning out really bright. This one's got very low voltage. I'm not understanding. Let's see if we can catch this on camera. Watch this far one. I can hear some noise in the speaker. Right there, it's burning. It's really bright. Why is it doing that? Alright, I think I figured out my mistake. This yellow wire right here goes to my high voltage universal bias supply. And I previously had it connected right here in the middle. This is the output of the two rectifier diodes where the rectified DC voltage comes out, follows this yellow wire to the cap can. Now this wire for the high voltage supply, or for the bias supply, was also tied in there. However, it needs to tap into the AC. So I moved it from this connection point to this connection point, and we should be good to go. Okay, I'm not 100% sure how relevant this is to the issue that I was having, but it's hard to say it can't be relevant. I put a new speaker. This is my baffle, and a couple of issues. First of all, the speaker was being held in with this group of nuts and bolts, and they were a little loosey, which I don't think is quite right. So I took it out, and what I did is I installed these four. And I'm blanking off the top of my head. You guys are probably screaming at me. I used one of those washers. I don't know if I have another one in my parts drawer that has the teeth on the bottom, so it actually bites into the wood. And then these were the only bolts I had. They were too long, so I had to use these spacers. So this speaker is now bolted in here quite a bit better. Number two, this baffle pretty much just fell out. There were some screws holding it in, but not super well. So I'm going to reattach some new longer screws to get that baffle in more securely as well. And I'm optimistic that maybe those things were related. So maybe that first speaker's not blown, but maybe just the way it was mounted, once it got to higher volumes, it just kind of started rattling like crazy. And that made it make those buzzing sounds. But this is an Eminence red coat. We're going to try it and see how we like it or we don't. All right, this speaker baffle cabinet situation is not going to repeat itself. I've drilled 3 holes. I didn't do the top one because the chassis is going to mount right here at the top, but I drilled 3 holes from the front. I put in some bolts and some washers and some nuts. And the baffle is not going to mess around. If anything, I'm wondering if maybe I'm going to lock it down a little bit too tight, but I can always back those off a little bit if I need to. I am going to put some of these screws back in. You can see these are the screws I used. For example, put them in here, and they just weren't quite long enough, I think, to really grab. So what I might end up doing is take a thicker drill bit and drill a little bit, just a centimeter or two, so that the screw, instead of sitting like this and biting in, it actually sits inset into this piece of wood. Might drive some screws in, just because I want to make sure this puppy's not messing around. And again, I got the bolts, got that red coat in there. This thing is prioritizing sturdiness and longevity. I don't want to mess around with this anymore. I want this thing to be rock solid, grab and go. All right, I had the amp all buttoned back up, plugged her in, started strumming a few chords. Amp made some sounds, but I was still experiencing some of the problems with like the muddy, farty, raspy, weird bottom end. Kind of played it for about 5 minutes. It was acting funny. And then I heard a little bit of a hiccups noise, and then it went dead. Not 100% sure how to move forward. Probably just have to take it apart again and start troubleshooting. So one of my initial reaction is some parts of this amp are new, some parts are old. The old parts includes the output transformer and the 6AU6 preamp tube. These are both vintage. So I tried a different 6AU6, didn't work. So honestly, my next thought is that I will probably try different tubes in every spot, but my initial thought is that the output transformer is dead. Which this output transformer, let's see if we can see it, it's down there. I'd taken it out of an old Hammond organ from the 1960s, so it's definitely old, and I think it's just giving up the goat. So I got a new one coming along the way. We're going to take this old one out, swap in a new one, see if that helps. All right, this is the original AO29 20936-3 output transformer. This is a little bitty thing. The AO29 is an interesting amplifier. It also used 6v6 tubes, but it had a whole host of it. It had like 11 tubes total or something crazy. So the output really wasn't ever intended to be that high. So this is a 50-some-year-old output transformer. Not 100% sure why I blocked it onto this piece of wood, other than I guess it made sense to me at the time. Probably had these screws, and these look like they're intended to go into wood. I don't know what I was thinking. We're going to take this thing off and take it apart and look at it and measure it and see if it's dead or alive. All right, here she is. Initial observations, I have forgotten just how tiny and wimpy these little AO29 transformers are. I mean, these things are old and very small. So, got a same stamping on there, AO-20935-4. Yeah, here she is. Let's, God, these wires are so old. It's crazy. So this was the secondary side. These wires were going to the output jack. This was the primary side. All right, I got the output transformer hooked up to the multimeter here. I'm on resistance on the lowest mode I can get, which is 200 ohms max. Now this is the secondary side. You can see we got this yellow wire here on the outside, the black wire is the center tap, and the green wire is here on the other side. The way I had it wired up is these two wires here were the ones going to the output jack. Now if we look here, you can see it's reading a resistance of 0.8 ohms. Which I don't think is good. I think you want to see some number of ohms larger than 0.8. That's like open. Now this is over on the primary side. These were the two wires that were going to the plates of the output tubes. You can see this is reading at about 0.5K, so 526 ohms. I think that's probably a little bit more proper. So to me, this secondary side, I have concern that it is blown, given that extremely low resistance rating. Okay, I went in my parts drawer, found some other transformers, and just been testing them. And actually, my initial hypothesis might not be correct. So this is a Hammond 1750E. I've got the black and green here. This is the secondary side, and it's reading 0.4 ohms. Then on the primary side, it's 151 ohms. So kind of consistent. The resistance on the primary side is definitely a little bit bigger than on the secondary side. All right, this is maybe a little bit unhinged, but I went through my parts drawer and I found this. This is a DSL40C output transformer from a Marshall DSL40. Now this output transformer was designed for about 40 watts with push-pull EL34 vacuum tubes. This amp had 6V6s, but I don't hate the idea of converting this thing to EL34s. So I'm going to take a look at my stash, see if I have a pair of EL34s, and I might actually see how this amp sounds converting it to EL34s. That means we're going to need to install this, and we're also going to need to rewire the pins on these two output tubes. But that is all very doable and sounds kind of fun for this little Frankenstein of an amp. So let's give it a shot. All right, I got this new / old output transformer on here. Just one thing to note is you want the power transformer and the output transformer on different planes. So you got the bells, so this one's running this way. That means the bells, this one's running this way. That's ideal. It might be even a little bit nicer too if we could have this flipped so it's pointing up this way, but this is fine. We're at 90 degrees to each other. We're running at different planes. That helps reduce the noise field between the two transformers. All right, I got the multimeter up. I've got the black lead on the black wire. When I go to the green, it measures at 0.4 ohms. When I go to the purple, it measures at 0.6 ohms. So to me, that matches this right here. Then when I keep it on ohms and I go to the other side, the gray, the brown, and the red, they're all open. So that's good. That's exactly what we want. So if we flip this over here, I'm going to put this on the gray. Let's test this out. Okay, so I'm pretty sure my guesstimation is correct. From gray to brown was 60 ohms, gray to red is 74 ohms, and brown to red is 134 ohms. If you think about this, why these numbers make sense, I refer back up to the wiring diagram. You have an iron core with wires wrapped, and on one side you should have continuity, but there should be resistance. So if the largest number here is 134, that's the difference between this one and this one because they're the farthest apart. And you can see the brown to gray and gray to red kind of splits the difference because the gray is in the middle. Same thing over here. The black and purple would be the furthest apart, so that's going to give you your 16 ohm output. Then the black to green gives you your 8 ohm output. This all seems to match. Now, the only thing of concern is my initial hypothesis that my old output transformer, it also had really, really low readings here. So I don't know for sure if the multimeter readings are confirming my hypothesis that the output transformer is blown. So all of this work might be for nothing. However, I'm not necessarily opposed to that because, to be honest, that old output transformer really wasn't cutting it. I got this beefy boy here. It was just sitting in my parts drawer. It also can make this amp EL34, which I think is kind of fun. I got plenty of voltage. I got power transformer current to make it work. I think it's going to be just fine. The only thing I got to do now is rewire these output tubes because the EL34s will have a different pin out. So I got to wire these 6 wires, and I got to rewire the output tube sockets. So a little bit of work to be done. Okay, I had to look it up, and actually I was wrong. The 6V6 pinout is nearly the same. The only difference is that pin 1 has a suppressor grid on this EL34, but the 6V6 pin 1 is unused. But everything else is the same. 2 is a heater, 3 is your plate, 4 is your suppressor grid. I'm sorry, your screen grid. 5 is the control grid. 6 is unused. 7 is the heater. 8 is the cathode. So I need to check on both of them. I don't have anything on pin 1, so I need to check that to see if I need to do anything with pin 1 and EL34. But other than that, it should be good to go. Alright, this amp still is not working. This is honestly kind of one of those situations where it's like, I think you fix one thing, but then another issue pops up, and it's kind of becoming hard to identify like what is the root cause of what's going on at this current moment. But these are the symptoms that I can describe. The amp makes no sound whatsoever. I tried using an audio probe and pinging the grids of each of the gain stages, and even if you ping the grids of the output tubes, there is no sound whatsoever going to the speaker. So that would tell me, I mean, maybe it's a problem with the speaker wire, the connection, the output transformer, the power tubes. Next, I took some voltage readings, and I was getting some strange voltage readings on the power tube, specifically related to the cathode. And like if you took a plate voltage, the plate voltage was fine. But then with this amp, on the cathode, I've got 1 ohm resistors from the cathode to ground that helps me. You due to Ohm's law, you can help bias through that a lot more simply. But then like my plate to cathode voltage readings were very strange. So my current question about that is I'm wondering if it's possibly has something to do with these tube sockets. And one thing I also noticed was that the tubes are having a very hard time inserting into the socket. Like if I put this one in, I give it some pressure, like it's definitely meeting some resistance. And I'm not 100% sure why. And I guess my current wondering is maybe, let's see if I can maybe use my camera to see it. I don't know if I can see it, but maybe there's something in there that's blocking, or maybe some solder flowed, meaning like when I was working on the amp previously, maybe it was the other way around and the solder flowed from the pin up into the, like these little crimps where these connections crimp onto. So I've got some new sockets on the way, but in the meantime, what I'm going to try to do is see if I can apply my soldering iron with the amp in this configuration, apply my soldering iron to each of the tabs, the socket tabs, and just see if I can get some solder to flow, hopefully down, to clear that up. Or I may also need to take like a flathead screwdriver and tinker around with these pins, but just doing a visual inspection, I can't really see anything. So, I don't know, strange things are happening. We're gonna keep trying. I'm not giving up. Alright friends, this is one of those moments where you see like a jump cut in the video editing, but what you don't see is that I have been struggling with this thing for about a month. And in all of the name of sweet baby Jesus, Mother Mary, Joseph, the wise men, I almost lost my brain. So, I think for a little while, honestly, I was kind of chasing my tail. I have a third output transformer. I think this one was working fine. I think the first one was working fine. Although the first one was that little bitty Hammond, it honestly probably needed to go anyways. I think the culprit coming out of the cathode, I was using these two, these little resistors. And they're little 1 ohm resistors. And through Ohm's law, you know, current times voltage, resistance, a 1 ohm resistor should give you the current. A measurement of the voltage there should give you the current flowing through that tube. Well, you can see with this little guy here, see how it's got this silver thing? I believe that what was happening was when I went to the solid state diodes, I was running a little bit more current through these things, and they maybe were just hanging on for dear life to begin with. And then with the higher voltage and current, from the larger output tubes, they just kept exploding. So I think what was happening was I was not getting signal flowing from the cathode to ground. So I've taken them out. I am currently running just a straight ground wire. So I'm going to need to bias it in a different way. It's going to be more of a pain, but I do have a new Hammond output transformer. Here, I'll show you which one. It's this one, 1760J, which I think is meant for like a vibro verb. Maybe a 40 or 50 watt 606 based amp. I got two 606 GCs. And if you guys want to hear one of the most wonderful sounds, I got a Eminence Tonker in there. I turn the amplifier on. Oh, baby. You can hear hum coming out of this speaker. It works. It's alive. Praise the Lord. So, I'm going to bias it, and we're going to start playing this thing. Okay, right now, you're looking at a reading of the plate to cathode voltage. It's settling in here as it warms up at about 401 volts on the plate, 400. Next, I go to Rob Burnett's website, his tube bias calculator, and I select 6L6 GCs at 26 watts. I enter my plate to cathode voltage. We're looking for about 26 watts. In class AB fixed bias, I usually go for the 60% average, which in this case would be 40, about 39 milliamps of current. Okay, so I documented my biasing research here. You can see at the top part here, I've got my output transformer center tap voltage at 405 volts. Then the plate voltages on tube 1 and tube 2 are both at 396. Turn the amp off, measure the resistance in ohms from the center tap to the power tube plates. I get two different readings, 86 ohms and 88 ohms and 96 ohms. Divide the voltage drop by the resistance to get the bias current. So my voltage drop is 9. And then 9 divided by 96 gives me 0.093, which is like 93 milliamps. So that's way off when I want to be at about 40. So then my second time around, when you turn the bias pot, it affects all of these numbers. It changes everything. So my second time around, my output transformer center tap voltage went up to 471. My plate voltage went up to 468, and the difference between the two narrowed. So now my voltage drop is more like 3 or 4 volts, and then that gave me a reading of 0.31, so I did tweak it just a little bit and ended up with negative 51 volts DC on the grid, which got me right to 0.04, which would be about 40 milliamps for about a 60% bias, and that was just right. been playing the amp some more, and I'm finding, as I listen to the clips and everything, the amp has a beautiful, beautiful clean tone. And one thing that is difficult to really translate is the increase in power, going from about a 20 watt amp with dual 6v6s to about a 40 watt amp, 50 watt amp with dual 6L6GCs. The amp has quite a lot more headroom. And the way that that translates not just to more volume, but like when you play loud, clean, you get so much, the bass notes just have so much more clarity and definition and crispness, and it just is a real pleasure to play. And so the only thing I was feeling was, as I turned the amplifier up, it definitely started to kind of break down a little bit. And so a little bit uncertain about this Eminence the Tonker red coat. I just don't know if that was the right speaker. So I do like to experiment with speakers. So I've got this Mojo Tone Greyhound, which is one I've been kind of curious to try out. I have had a good experience with Mojo Tone products in the past, and I'm very eager to try out their speakers. And so this is a brand new Eminence Greyhound. It's supposed to be kind of a mix cross between an American and a British style speaker. At 70 watts, it should work fine with this circuit. At 40 or 50 watts, we've got a little bit of headroom. And so I'm going to try putting it in, and let's play it and see how it sounds. All right, I hope you guys enjoyed that adventure. I want to kind of recap what we went through and what we learned, just because sometimes the cause and effect relationship with these things can be hard to pin down. And as I grow in my amp building and a tech experience, I think this is helpful for me to process. So let's kind of recap the things that we did, give them a little bit of a rating on whether it was successful or not. So started off wanting to tweak the voice of the amp a little bit. First of all, just the subtle tweaks that I made to the tone stack made the amp a little more of a black panel spec, and I think that has been a subtle but very nice improvement. It meshes well with my pedals. The scope and the range of the bass and treble and mid controls works a little bit better, so I'm just really happy with that. Second, I had designed the amp to have switches on a cathode bypass cap and the negative feedback. And the thought process there is with a switch, for example, with negative feedback, you're just giving yourself more of a tonal option, but you're not really taking anything away. In practice, though, those switches weren't very effective, and I really only had one effective setting, which was basically maximum gain, because the preamp is a little bit cleaner in this amp. And so I think it really just makes sense to hardwire it. Learn from that experience. In some ways, having extra needless complexity just is not better. It's better to know the function purpose of this amp, to have a robust and well thought out design, and to stick to it. And so in the hindsight, I'm happy to have this thing in a little bit more of a simpler, dependable, set it and forget it type situation. Now, where the amp took a left turn probably starts back to when I went from a tube rectifier to solid state diodes. I don't entirely regret that because my preference through the years has moved away from tube rectifiers to solid state diodes. Tube rectifiers are less dependable, they're more likely to burn out or need replacing. Solid state diodes have a little bit more of a firmer feel, but they also produce a higher voltage in the amp. Now that kind of classed me out of the 6v6s up into the EL34s or the 6L6GCs. The problem there is that my cathode bias resistors, it's really the connection between cathode and ground in a fixed bias amp. I had 1 ohm resistors to measure the bias. Those resistors were underpowered, and so I'm not sure if they were 1/8 watt or 1/4 watt, but want to make sure, and one of the things I've ordered now is maybe some 1/2 watt, 1% spec, 1 ohm resistors that I can put in these amps, especially the higher powered ones. And that's something I'm probably going to go back through my other amps and make sure. I've got a 50 watt plexi, I've got a train wreck, I've got a super reverb. All those amps are running 50 to 60 watts. I want to make sure that those cathode connections are flowing plenty of current down to ground. It's a pretty necessary and critical part of the circuit. So I'm glad I discovered that, but it took me a while to get there. Had a little bit of a runaround with EL34s, and then ended up with 6L6s. Could have just as well stuck with the EL34s if I had discovered that cathode problem. But either which way, I'm happy with where I've landed. The new output transformer is a huge upgrade, and the 6L6s have quite a bit more power, headroom. I can set this amp clean at a gig volume level, keep up with a drummer and a bass player and a vocal monitor, and still hear myself really well. It takes my pedals really, really well, and really more than anything, I notice on the low frequencies. I think with the old output transformer, that little tiny 15 watt from the Hammond organ and the 6v6s, it just didn't have enough oomph to really push those low-end frequencies successfully. So pretty thrilled with that upgrade here. Then lastly, the speaker cannot be overstated. I think this final new speaker is a big upgrade. Those other 2 speakers I think were a little bit worn out or maybe underpowered for this application. And I'm not sure if there's a problem with the voice coil or something, but any which way, this new speaker has brought a lot of new life and freshness and tightness and gotten rid of some of that raspy problem that I was having. So all in all, I've gotten the amp to a really nice spot. I'm thrilled to have this in my arsenal again and to be out and gigging it hopefully here soon. So please let me know your thoughts down in the comment section below. If you made it this far, you were a legend. Please stay tuned, subscribe. I've got more projects coming soon. Love to hear from you guys. See you again soon. Thanks, bye.